and welcome to today's webinar, Amazon Aurora for Enterprise Database Applications. Our presenter today is Abdul Said. Abdul is a Principal Product Manager for Amazon RDS. Prior to this role, Abdul was a Principal Solutions Architect, focusing on databases and enterprise applications on AWS. He has over 24 years of experiences in software engineering, product management, architecturing, and product marketing functions at leading tech companies. Prior to joining AWS, Abdul spent several years at Oracle. Today with us, we also have Scott Ward, Solutions Architect at AWS, Shandor Maurice, Software Development Manager for AWS Aurora Database, and Lynn Ferentine, Business Development Manager for Databases. Scott, Shandor, and Lynn will engage with you and answer your questions throughout today's presentation while Abdul presents. Abdul, welcome, and now pass the floor to you.
And once again, welcome to the Aurora for Enterprise Database Applications webinar. Hopefully, many of you had an opportunity to look into Aurora at least briefly and probably get an introduction to it before. If not, we'll do a little bit of that here. Aurora is Amazon's own database engine that we released as a managed service in late July last year. It was in preview for about 8 months, where a lot of people got an opportunity to experience this firsthand. And then once we went GA in late July, we have seen a tremendous response to this product, and a lot of people started using it for production workloads as well as new development from all across the board. We have seen people migrating from MySQL workloads, from Postgres workloads. Some customers came from NoSQL databases. I'll talk about it a little bit, about some customer experience in that space. A lot of customers migrating from commercial databases like Oracle and SQL Server. In this webinar, we'll primarily focus on how well Aurora fits the enterprise database application landscape and the features and capability of Aurora that makes it a perfect candidate to be used for enterprise database application. If you look at the entire landscape of database usage by different industries, by different size companies and sectors, you'll see the requirements, needs, and preferences of these different segments are kind of like slightly different, though the underlying requirement of being able to store data and have high performance and availability kind of like is a factor that influences any of those workloads. But if you go between like startups and web applications and enterprise applications, the kind of needs and the kind of needs and requirements and preferences each one of those segments of customers have is slightly different. And when it comes to enterprise databases, enterprises focus quite a bit on availability, security, performance, and scalability. After working in the database field for about 25 years now, I have tremendous respect for the position of database in the enterprise IT landscape. A lot of things depend on the database. You can swap out applications, switch from one application to the other, change operating systems, change the servers, the basic infrastructure or the network configurations, but it's switching from one database to the other or selecting a database for a workload is a very important decision. And that's a decision that's made based on these preferences that I just mentioned to you. So when it comes to the wants and preferences and wishes of enterprises on the database space, many of the enterprises are now looking for managed services where the complexity of installing or implementing and architecting and installing and maintaining and managing the database can be brought down quite a bit, because this is a major task for any business. especially if the business is running a large number of databases. I have seen many enterprises that has like 10, 15, 20,000 instances of different databases running for many major production workloads, as well as a development test, integration test, the whole suite of different segments of applications that you see in an enterprise. So when you have that kind of large number of databases that are being used, just managing them and maintaining them becomes a huge task. Having a managed database service cuts down on the amount of work required to keep this up and running and having it tuned and performing in the best condition. So now when we looked at the existing database engines that are available in the market, we saw basically two different sectors. One is the commercial databases like Oracle and SQL Server, and then there are open source databases like MySQL and Postgres. Both of them have their own advantages and disadvantages and pain points. Businesses mostly tend to use commercial databases, but I have yet to come across any business that uses commercial database, a commercial database engine, and is completely happy with every aspect of running it. Especially when it comes to the constraints and the restrictions that come with the licensing of the database and the complexity that is involved in setting it up and maintaining and patching and whatnot. So if you look at how these traditional databases that have been in the market for a long time work, they all basically architected and designed a long time ago. When they all came into existence, they were breakthrough technologies. That was probably like 30, 40 years ago, and then a lot of development have been done on top of it. But most of that development has been on top of the core database functionality. A lot of features got added to the databases. Clustering got added. There are additional external tools and applications that were brought in to provide high availability and additional fault tolerance and replication and whatnot. But the very core of the database remains still the same. So when we looked at the existing databases and thought about, this is a great place where we can help our customers get rid of the pains that they have today when it comes to the commercial databases and move towards something much more flexible, much more powerful and performant and scalable. What can we do? We basically went back to the drawing board to figure out what exactly is wrong with what was available in the market or what is available in the market today from both commercial as well as open source databases. Now, because of the constraints, the restrictions on licensing and the cost involved and the high level of complexity and the expertise needed for setting up and maintaining the commercial databases, a lot of people have started looking into open source databases like MySQL and Postgres a few years ago, and many businesses started using them for smaller workloads, for custom applications that are built in-house. Some of the businesses, some of the enterprises even migrated some of the smaller workloads, smaller databases into MySQL and Postgres. But many of them came across wanting more, being not totally happy with the performance these provide compared to the commercial databases. So open source have its sweet spot. They're very inexpensive, pretty much free when it comes to licensing. There are no constraints when it comes to licensing, so you can run in any size server box without being worried about being compliant or not. There's a large number of developers who are contributing code to it, so it's keep getting updated and getting new features and whatnot on a regular basis. But still, when it comes to performance and the additional capabilities like high availability and replication and whatnot, they still fall quite a bit behind commercial databases. So when we looked at it, we came up with the idea that if we can build something that provides the same kind of performance or better performance, availability, reliability, and security of the commercial databases, at the same time make that available at the cost or less than the cost or around the cost of the open source database, that would help our customers quite a bit. That's what we did when we went back to the drawing board and started working on Aurora. So if you think about the traditional databases, they all have a monolithic design. The SQL processing, the transactions, the caching, it all happens on a single monolithic stack, making it kind of like a bottleneck, kind of inefficient in a way how it works. And this worked really well in the old times when you're running everything in one server, one big box, and the only option that you had to get better performance or scale the operations in the database was to go into an even bigger box, which requires additional procurement and downtime and a lot of planning and whatnot. Now with the cloud architecture and all the nice services available from AWS when it comes to the EC2 instances that you can keep adding to scale vertically or horizontally, EBS and the software-defined networking that we have, the VPN-based network isolation we provide, a lot of different pieces that are available in AWS. We thought we can do a much better job when it comes to redesigning the database and making it completely different from what the traditional relational database, how the traditional relational databases work underneath, but still make it work in a similar way and provide a similar kind of functionality at a much higher and better rate than the traditional databases do. So Amazon Aurora is purpose-built for the cloud, using cloud technology, designed from the ground up, making the best use of what AWS has available. What we did when it comes to design is something quite radical. We took the service-oriented architecture that usually was synonymous with a well-defined, well-designed distributed application. We took that and applied that to the database. So we brought the service-oriented architecture to the architecture of the database by splitting out the SQL processing and transaction processing from caching, from log and data block processing. So we split this out, made it into different components for better performance, better reliability and resilience, as well as being able to asynchronously and parallelly process these things, thus extending the performance gain as well as bringing in more resilience into the architecture. Anytime we talk about enterprise database, normally the conversation starts with security. How secure is the database? What are the security features that are available in the database? How I can protect my data? This is especially important because when it comes to large businesses and enterprises, a lot of data that's available with them are quite frequently governed by regulations. You could have personally identifiable data. You can have data that can be accessed only a specific category of people. It's, any business that handles customers' data, it's important for that business to take care of that data so the customer's data is never compromised. Aurora provides top-notch security at every level when it comes to the database. Aurora is available only within Amazon VPC. So when you launch an Aurora instance, it automatically comes inside Amazon VPC. VPC stands for Virtual Private Cloud, where you can carve out a part of Amazon's network just for yourself. It's a virtual private cloud just for you, with that nobody has access to. It's totally isolated. Nothing can access anything that is inside, or nothing inside can access anything outside of the VPC without setting up, special opening special ports and setting up gateways and whatnot. You can also set up your own IP addresses for all the infrastructure components that you place inside the VPC, making it an extension of your own network. So by default, and when you launch a Aurora instance, it gets launched in the VPC, giving you that isolation at the network level. Now, a couple of months ago, we released encryption at rest for Amazon Aurora. So now you can encrypt the database using KMS, which is our key management service. A key management service is a service available through AWS where you can go create new keys, rotate keys, and manage your own encryption keys. So now you create, you define, and you manage the keys, and using these keys, you can encrypt your Aurora database. And using KMS and using encryption in Aurora also is pretty simple and straightforward. There's no complex setups involved. Basically, when you launch the database, there's a drop down where you go and specify that you want the database to be encrypted and pick the key. If you didn't have a key available, you can go to the KMS console from there, create your own key, come back, use and ask the database to use that key to encrypt the data when it comes up. Once the database is encrypted, everything that is now related or taken off from the database also are encrypted, which of course includes the data that's in the database, as well as the automated backups and snapshots, and any replicas that are set up in the same cluster will automatically be encrypted. Now, the best thing about this encryption is it's totally seamless. As the encryption is at the storage level, once you define the key, we'll encrypt the underlying data at the storage level, and any application that has proper authentication to access the data from the database, when they request that data, this encryption system automatically uses the same key to decrypt and provide the data back to the application. So basically, there is no change that you need to make in your application to make use of encryption. And then after security, of course, the next trait that anybody looks for in the database is performance. And Amazon Aurora really shines when it comes to the performance that's available from the database. Recently, InfoWorld did benchmarking of Amazon Aurora. You can see a snapshot of the report on the screen. This report is available to download from the Aurora website as well. Just go to Amazon Aurora website and you'll see the link there to go download the InfoWorld full review on this. InfoWorld actually found in their test the performance, both read and write performance, to be slightly higher than what we normally put it out for customers to know. And InfoWorld actually says, InfoWorld picked Aurora as the editor's choice and says, it's a really formidable alternative to Oracle and SQL Server. Now let's look at the numbers that we have seen in our tests. This is not just one test. This is after doing a battery of tests that give us, much higher performance numbers many other times. So this is kind of like the consistent numbers that we have seen on a regular basis. And this kind of numbers are actually, really good performance numbers for any database. And when it comes to a database that is totally new in the market and the one that we continually working on to increase the performance and reduce the time for failover and whatnot, and add new features, you can see this as just a starting point, and that itself is tremendous performance improvement on most of the databases that are available in the market. So we have actually a white paper or guide for for you to do the testing yourself. So you can just go to Amazon Aurora website, download the Sysbench benchmarking guide, and follow the instructions and see for yourself how Aurora performs under heavy load or light load, or depending on what kind of workload that you will be throwing at it. So we have consistently seen over 107,000 DML writes per second and 585,000 reads per second. This is on a R3 8 extra large with 32 cores. That's kind of like the largest instance type available for Aurora. And these were based on with a single client and working on 1,000 threads. So when you follow the instructions, if you want to do the testing yourself, when you follow the benchmarking instructions, there are different ways you can increase the connections to figure out how these numbers change based on how you do the testing. The next thing we did was we took Aurora and compared it head-to-head with MySQL. And if you consider installing MySQL, there are a lot of things that you can optimize at the MySQL level, and our RDS for MySQL service available has implemented all those best practices in MySQL implementation. So probably one of the best configuration that to test MySQL to see MySQL performance is probably RDS for MySQL. So that's what we did. We went with RDS MySQL and also put MySQL on EC2 and compared the performance of MySQL for both writes and reads against what Aurora provides, and you can see that table there. One of the very interesting things that you can see here is how the performance of Aurora is consistent compared to what MySQL provides, whether it is on RDS or on EC2. So on EC2, we went with the largest and the beefiest instance possible, which is I2 8 extra large. I2 8 extra large is even more powerful than R3 8 extra large, and the I2 instance has a large amount of local SSDs. So we did the MySQL install in EC2 and I2 8 extra large using the local SSD, so we can completely avoid the network latency and jitter. We also tried it with I2 8 extra large with the whole thing in the RAM disk, which is very interesting. And then we compared this with RDS for MySQL with the highest possible IOPS, which is 30,000 IOPS, and then comparing with Aurora. You can see with 10 tables, Aurora has a write throughput of 60,000, whereas RDS for MySQL has 25,000. Interestingly, the MySQL on EC2 that we did on I2 8 extra large, whether it is on RAM disk or local SSD, still falls short of RDS. As we increase the number of tables, which will be the case for most of the enterprise applications, I have never seen in my life any enterprise database applications using 10 tables. Normally we have thousands of tables with a large amount of data. So that is where you can see Aurora really shines. Aurora works well for pretty much any kind of database workload, but as it gets more and more demanding, as the amount of data increases, as the number of tables increases, as the number of connections and the data ingestion requirements increases, that is where you'll see a real huge difference between Aurora and most of the databases that are out there. So if you look at this table here, as we increase the number of tables from 10 to 100 to 1,000 to 10,000, you see between 100 and 1,000, the difference in Aurora performance is pretty much negligible, going from 6,000 to 64,000, whereas on MySQL, whether it is on RDS or on EC2, it's substantial. On EC2, it's going from 19,000 to 7,000 writes, and on RDS, it's going from 23,000 to 8,000 writes. Almost like a 70% decrease in the rate of writes, Whereas in Aurora, it just went from 66,000 to 64,000, which is just about like 3% degradation. And when you go from there to 10 times the number of tables, again with a large number, 10,000 tables, in Aurora it goes from 64,000 to 54,000, which is just about like 15%. And for MySQL, whether it is RDS or EC2, you can see again another substantial decrease of about 50%. Now let's look at the same thing with the number of connections. So this again is a real world scenario with most of the enterprise applications. You are not going to have small number of connections with the database. Most of the databases are usually serving a very large number of users and many different applications. So there are usually a large number of concurrent connections. Let's see how the write scales with the number of connections between Aurora and MySQL. And after doing the testing of MySQL on RDS and EC2, we figured out, pretty much always the RDS MySQL outperforms EC2. So in this case, we did the comparison. I have the comparison table only between Aurora and RDS for MySQL. You can see with 50 connections, the write performance for Aurora is 40,000 versus 10,000 for the largest instance with the largest IOPS available for MySQL. So there itself, it is 4 times. Now, as you ramp up the number of connections, that is where you see the biggest difference. When you go from 50 to 500 to 5,000, and see at 5,000, Aurora write performance goes from 40,000 to 110,000, whereas for RDS for MySQL, it goes from 10,000 to 13,000. So that's a really substantial difference. Now, how do we achieve this? We do this by, interestingly, by doing less work. So when you look at MySQL, you can see this is a comparison of how these writes happen in MySQL versus Aurora. In Aurora, we use a huge, probably the world's largest multi-tenant, highly redundant storage and network storage underneath. Whereas for RDS for MySQL, or whether you are using MySQL on EC2, basically what you are doing is you are connecting to a single volume of EBS on the other end to which you are actually writing. Now, when you go to multi-AZ architecture for MySQL, if you are doing it on by yourself, by setting up a standby in EC2, or you using multi-AZ in RDS, which is obviously the better way to do it, you see how the writes progress. We are actually writing from the primary instance to the primary storage. Now the primary storage, which is EBS, is a mirrored storage, so there are 2 copies of it. So from the primary EBS volume, it gets returned to the mirror, and now from the primary instance, we replicate the data to the standby, and then the standby writes it to its own EBS volume, and from that EBS volume, it writes to its mirror. All this is synchronous till all these writes are done, no ACK comes back. So basically, we have to wait after you push a transaction to the storage. You have to wait for all these writes to happen before it comes back, causing a substantial amount of latency, whether it is latency from network, latency from the IOPS, and latency from the write. So different levels of heavy utilization of the resources. Now, versus if you look at Aurora, one thing that is very different in Aurora is the way we push the data from the Aurora instances to the storage. In the database architecture itself, we basically took almost like 25% of the database code or database processing and pushed it down to the storage nodes. So there's a lot of stuff that is happening in the storage nodes, and we don't really push data blocks from the Aurora instance to the storage. All that we push is the the logs, the log records. We kind of like batch the log record, box card them. When there's enough volume to push through to the storage, we push them to the storage node. Then it gets distributed across these multiple nodes, 6 nodes across 3 different availability zones. All that happens in parallel. The writes happen in parallel. We have a quorum-based write technology where once 4 out of these 6 writes are done, it acts back so your database can proceed to the next transaction, thus heavily cutting down on the number of writes as well as I/O and the network traffic. Some of the tests that we have done kind of like prove that we are cutting down the network traffic and I/O by almost 90% in MySQL versus Aurora. So it's actually doing a lot of this where we are actually doing less work and doing it much more efficiently than what MySQL is doing, and potentially how a lot of other databases are doing. That is what gains so much efficiency and performance when it comes to what Aurora does. I'll just skip through a couple of these slides to get to something that is more relevant for the enterprise workloads. We actually have another webinar that I did a couple of months ago called Amazon Aurora Deep Dive. We will have it again after a couple of months, where we really go under the hood to explain how exactly Aurora works when it comes to every one of these aspects, whether it is storage or managing the network throughput and cutting down the number of packets per second that is pushed through the network. It's a very interesting webinar, very interesting session, originally done by the VP of Aurora, Anurag Gupta at reInvent last year. We just represented it in the webinars. I couldn't be as interesting as how Anurag did it. You could find it on YouTube, go check it out, or you can attend some of our future webinars that's going to talk about Aurora Deep Dive. So let's come back to the aspects of Aurora that are more suited for enterprise database application discussion. So after the obviously after the performance discussion comes the fault tolerance. How reliable is Aurora compared to the other databases available, and as well as the reliability of Aurora, how does it suit the enterprise application requirements that you have. Again, like I mentioned previously, we took that monolithic design and broke it down into caching in a separate layer, SQL and transaction in a different layer, and then storage in a third layer. And a lot of innovation in Aurora actually is in the storage layer. There's a lot of stuff that is happening there. It is highly available by default. When you implement an enterprise a commercial database, there are a lot of things that you manually install and implement and configure to make some of these capabilities available to that kind of database. Normally when you install and configure a commercial database, you set up replication across 2 different storage systems. So if one storage system goes down, you still have the other one available. And here in the case of Aurora, we went far ahead of those two, the 2 storage system for redundancy. What we are doing is we have 6 storage systems, 6 storage nodes where we are storing all the data the write is done asynchronously, but the data is pushed to the storage node synchronously. So basically it gets written in 6 places. It's a 6-way replication with a 4 of 6 write quorum, like I mentioned previously. So once the 4 out of the 6 writes are done, we can continue doing whatever else, and the other 2 gets done at some point of time. On the storage side, we also have a ghost protocol that actually where the storage node peers talk to each other, making sure they're all in sync and filling out the holes if there are any. There are other processes that go around scrubbing data because eventually the data is stored on disks. Now the disks are much more reliable than they used to be 20 years ago. This is SSD based storage, but the disk storage deteriorates over time. So we have scrubbing processes that go around because we have the luxury of 6 copies of the same data. It compares block against the block to make sure all the blocks are consistent. If not, get it out and get a copy of a good block from somewhere else and replace the bad block. We have hotpoint management where the other processes are going around looking for hotpoints in the storage and replace them or distribute them out. So there's a lot of stuff that happens under the hood on the storage side. Usually when it comes to enterprise databases, a lot of thought goes into architecting the database, budgeting for it, procuring it, and setting it up. Because these are time-consuming, costly procedures, normally people kind of like plan it out for a long period of time, because you cannot go just buy new storage or new servers or new licenses every 6 months or every 3 months. So most of the time when you do databases on-prem or in your own data center, you're actually procuring storage and procuring capacity and capability for 3 years from now, not from today. So if your database is today at 1 terabyte, you estimate it's going to grow to 6 terabytes from 2 years from now, and you want to get enough storage to be able to serve you for 2 years from now. So now your 3 terabyte storage that you bought is actually 3 times what you need today. Because AWS is completely elastic and scalable, you don't need to provision anything for what you need for the future. All you have to do is provision what you need for today. And Aurora takes it a step further by making it automatically scalable. So the storage is completely automatically scalable. You can have databases up to 64 terabytes in size, which is a substantial size for any kind of database. Normal enterprise database size tend to be between 8 and 18 terabytes. So there's plenty of leg room to grow into any kind of database size that you might have need for. And the beauty is you can get started with a really small database and not worry about the space you need. Aurora will automatically grow the size of the database up to 64 terabytes as you grow and as you need. And you are going to pay only for what you are using. So unlike in the traditional implementation where you are buying the storage and the server for 3 years from now, in Aurora you are just buying it for today. And the storage is self-healing and fault-tolerant, like I explained before, because we have 6-bay replication distributed across 3 different AZs, and we need only a quorum of 4. You can see in the diagram, we can tolerate 2 different nodes going down in 2 different AZs, or we can tolerate a complete AZ going down, and we'll still be fine. And when any of these things happen, we'll automatically do a host replacement. We'll automatically replicate data and set up a new storage node. So all of this is going to be transparent to you happening under the hood, no matter what kind of failure happens at this level. If any of you are DBAs, you know the pain involved in backups. It's something that has to be done to prevent a catastrophe. If your database goes down, your database crashes, you lose your data, or for regulatory purposes, you need to be able to get the data from the backup and be able to restore the data to a point that you need the database to be at. Now, to do this, normally we, in the traditional database sense, we do cold backups and hot backups. Hot backups are normally continuous. You do like every 6 hours, every 12 hours, sometimes 24 hours. Cold backup, some people do once a week, some people do every night. So you get a complete snapshot of the database after shutting it down. So now all these backups has their own issues and complexities involved. One, cold backups needs shutting down the database to be able to take the cold backup. When you're doing hot backup, that is going to affect the performance of the database. And then the other thing is how and where you store the backup. When you take the backup on the tape is not very reliable. You probably take the backup on the disk and then cut it to a tape and ship it out for to store in another location, because you want some locational redundancy as well, just in case your data center goes down. You want to be able to access the data from somewhere. So you want to store a version of the data outside your location. Now think about all the complexities and amount of time and effort involved in doing all this on a regular basis. And then when you want to restore the data, just having go through the whole thing all over again to find the right tape from the right place to be able to restore, and many times find out the tape is damaged or there's something wrong with it. Aurora completely solves all these problems for you by continuously backing up to S3. S3 is our AWS flagship object store with 11 nines of durability. So what we are doing here is there is no separate backup that you need to do. The backups are happening in real time continuously into S3. And we don't consider the data in Aurora to be completely persistent till the data actually goes into S3. So the backup is automatic, backup is continuous, and the restoration from the backup at any point of time is totally painless. And then the other thing Aurora provides is instant crash recovery. In the traditional databases, to do the crash recovery, you go back to the backup, you restore from the backup, then you replay the logs. All this takes a while to get to the point that you want to get to. Whether this is MySQL or the commercial databases, the story is the same. But when it comes to Aurora, because the underlying storage itself is based on logs, not on data blocks, all this is so much more simpler. And our storage is divided into multiple tiny segments. So when you have a crash and recover from the crash, even the application of the redo logs happens in parallel, asynchronously. So basically you are coming back instantaneously, and the redo logs getting applied on demand as needed. One of the major requirements when it comes to database for most of the enterprises is availability. So availability means you have the database up and available all the time, and if something happens to the database, there is a standby that you can fail over to, and everybody would like that failover to be as short as possible. Now when it comes to Aurora, we have done a lot of optimization in that failover mechanism. If you have your primary instance of Aurora running with a read replica, this read replica can be promoted as the primary anytime. So if your primary goes down, your read replica automatically becomes the primary. And in the diagram you can see how failover works. The top one is the failover for MySQL RDS, and you see the largest amount of time that is involved in a failover is DNS propagation and recovery. Since recovery is instantaneous in Aurora, that becomes so short. And if you are using MariaDB driver that we work with MariaDB folks to develop, it's a great driver to use for Aurora. MariaDB driver automatically finds out what is the other database instance to fail over to by querying some database system tables instead of waiting for DNS propagation. So you're avoiding the DNS propagation as well. And now with such a extremely short recovery period and avoiding DNS propagation, is going to allow you to do a complete failover in about 20 seconds, which is really good. Now all the stuff that I told you about, all the features and capabilities of Aurora, you can test all this out. You can cause failures and simulate different level of failures like network failure and disk failure, and see how Aurora reacts, and is that good enough for the kind of application that you are going to use Aurora for, by using these SQL statements that we have available to Aurora. So you can simulate system crash, you can simulate disk crash and network failure and network jitter, and see how Aurora reacts yourself. Now, since we can do a lot of what we do that I mentioned so far, is because Aurora is a managed service. So we have designed, architected, built, and tuned everything for you, so we can make all this available to you with just a couple of clicks. So we, through the RDS platform, we take care of all the time-consuming redundant tasks like backup and recovery, isolation and security, monitoring, patching, and all those things that are involved there. A couple of weeks ago, we have launched the enhanced monitoring for Aurora. Enhanced monitoring makes available 50 system-level metrics to you. This basically, you see what we see. You can use this. You can use Aurora console to watch and put alerts or whatnot on these different system events, or you can use APIs to consume this data and bring into whatever else tools or application that you use. You can also use this with a lot of industry standard monitoring tools and dashboards that you might be already using, like Datadog or Cloud Health or New Relic. The Aurora or RDS Enhanced Monitoring works very well with all these tools, allowing you to bring this kind of monitoring data from all the applications that you're using, as well as all different components of AWS and the other infrastructure that you're using in your own network, everything together in one place in the tool that you use for monitoring and subsequent action. Now, you are really impressed with Aurora, you really like Aurora, you want to see how you can bring your databases into Aurora. For that, we have introduced a new service to make things easier for you. In February, we have a webinar that is specifically about the database migration service. Make sure you attend that webinar. Data migration service is a new service where you can basically point to a source database that you want to migrate to Aurora, or any other database on AWS side, whether it is on RDS or EC2. And just with a couple of clicks, you can get the migration started. You can migrate the database while your source database is still up and running, and your applications are still working with the source database. The data gets migrated seamlessly into Aurora or into the target database, and once everything is done, you can test it. You can keep migrating data as you are testing, and once everything is done, you can shut down your source and switch over to Aurora. We even provide, this is kind of like how the database migration service works. You basically point the migration service to your source database. The source database can be on EC2 or on RDS, or it could be in your own data center, and point that to Aurora or any other database on AWS for that matter. Pick the kind of instance that you want to run database migration service on, and click go. And that's pretty much all that you do. And the data over time, depending on the size of your database, it might take a little while, it might take a few hours to migrate that data over. And since this is being done without affecting your source database, without shutting down your source database, it's not interrupting anything you are doing, it's not interrupting your business. The data completely comes over, and when it's all done, you just point your application to the new database and you're ready to go. Now, I mentioned Aurora is fully MySQL compatible. That means if you have MySQL database that you want to migrate to Aurora, it is a straight migration. Your code is going to run completely fine with Aurora with no changes. your stored procedures and functions and triggers, everything is going to work just fine. There's no data type conversion required. It's all easy. But if you are migrating from some other database like Oracle or SQL Server, things are a little different on the Aurora side. These databases are not 100% compatible. The code, the stored procedures, the packages, the triggers that you have in Oracle might not work in Aurora. To make this easier for you, we have provided another tool called AWS Schema Conversion Tool. AWS Schema Conversion Tool makes life easier by scanning your source database and then converting the data types and converting the code that you have in the database, including your stored procedures and functions and whatnot, to fit the standard required for Aurora, which is same as MySQL. The schema conversion tool is actually really good in converting database objects like tables and indexes and whatnot and the data types. And when it comes to complex code, in most cases, it is able to actually today able to take care of up to 80% of code translation. So if you have a stored procedure which is not very complex, you'll probably be able to translate it 100% and make it work in Aurora. If it is too complex, you'll probably be able to translate 80% of that code and point out which part of the code it's not able to completely translate, so you can manually do it yourself. So the AWS Database Migration Service is an open preview now. You can go to aws.amazon.com/DMS and launch DMS and try it out yourself. So basically this summarizes everything that I was telling you so far on why Aurora is an excellent fit for enterprise applications. It's the reliability with the 6-way replication, continuous backup, the performance, and above all, the freedom from constraints of licensing. No enterprise application that I have ever worked requires just the same level of performance throughout the month or throughout the year. A lot of times you have spikes, you need more performance during the end of the month when you are closing out the financial books or when you're doing the payroll or if you have a e-commerce application powered by the database, you'll need this extra horsepower for 2 months a year during the whole holiday period. For the traditional commercial databases, you buy licenses and you provision infrastructure to take care of that top load. That means for 10 months of the year, you are paying all that extra money just for what you need for that 2 months a year. Not with Aurora, because there are no licenses installed, there are no constraints, you can scale up and down as you need, and Aurora happens to be total cost-wise 90% less expensive compared to any commercial database available today. With that, I'll turn back to Bowen.
Great, thank you, Abdul, for the great presentation. So now we have 2 minutes left. If the audience can take a moment to fill out 3 poll questions to the left on your screen, it can help improve our webinar programming. And again, thank you, Abdul, for the presentation on Aurora for enterprise applications, and also for Scott, Shendu, and Lane helping out with lots of audience questions. In the next few days, you are going to receive an email with the on-demand links to the presentation deck and also the webinar recording. So thank you again, audience, for your time today. Enjoy the rest of your day.
All right, since we have 2 minutes left, I'll go through some of the questions that are not already answered. I have a question here: how can Aurora be compared to Redshift? Redshift is a petabyte scale analytics database. So for like data warehousing and analytics, that's where you go. It is, from the commercial side, it is comparable to Teradata or Vertica or Oracle Data Warehouse, just at much higher performance and much lower cost level. Whereas Aurora is very similar to a traditional relational database that you will use for OLTP and that kind of transactions. When would Aurora be available in Singapore region? We are actually rolling out Aurora region by region now. We initially rolled out only in the US, and then it was available in, we made it available in Dublin. It was made available in Japan after that. Now there are a few regions that are going to come up subsequently in quick succession. One thing that we need for Aurora, one thing we need in the region to make Aurora available is 3 availability zone. You saw you have 6-way replication, and that requires 3 availability zone. So Aurora initially is going to be available only in the regions that has 3 availability zone. Singapore is definitely in our list of things, and we have a lot of customers in the Singapore region, and we'll work hard to make it available there. Okay. So that kind of like wraps up our webinar. Thank you very much for taking our time today. We really appreciate you attending the webinar. Hopefully this has been very helpful for you.